All right, so after talking about the variables, now we move on to methodology. Okay. So we still talk about the design part, right, where you should have a background introduction, variables, and now we move on to methodology and risk assessment. Okay. So what is methodology? Methodology means that you need to let the marker know uh, how are you going to change the independent variable, how are you going to control the some of the variables, and also how are you going to find the dependent variable using procedures. Okay. So in the first part of the methodology, uh, if it is a very unfamiliar methodology, then you should provide a background information to it. One of the examples, let's say you are actually using spectrometry, like visible spectrometry, because you want to determine the rate based on the change in color. Let's say that's the example. Okay. So you might want to provide some of the background information on how are you going to use spectrometry to find the concentration of the solution. Let's say it's this way. Okay. Uh, so for the methodology part, you can actually talk about it when you're providing the background information. That means the parts where I talk about in the last two videos. Okay. Also, of course, you can put it right here as well. Okay. After talking about the introduction, then you need to provide the material list and the chemical list. Okay. For the material list, that means the apparatus. If that particular apparatus has uncertainty, please list it out as well. So if the setup is complicated, okay, it would be great that you add a diagram with annotation. So remember the diagram should be in 2D. Okay. Uh, Annotation is very important if you put in a diagram. But let me emphasize that if it's a standard procedure, okay, it should not have a diagram. For example, for titration, every marker knows that there is a burette and there is a conical flask. So in this case, adding a diagram doesn't help. Okay? But let's say it's a setup that maybe you set up yourself. Okay, maybe it is a combination of different apparatus, but you kind of make your own adjustment. Okay? And in this case, then it would be great that you plug in a diagram. Okay, so it's either hand drawn, okay, or if you think that drawing out that setup is too difficult, then you can actually take a photo. But make sure in that photo it doesn't have your classmates in it. Okay? And then after the setup, then is the procedure. Okay? I'll talk about it one by one. Okay, in detail about the procedures here. Okay, so for the procedures, the rule of thumb is it should be able to let the marker do the whole thing again. Okay, we call that reproducibility. Okay, imagine the marker is looking at your lab report. Okay, he should be able to do it again. Okay, this is what we call reproducibility. Okay, it should be clear. Okay, and the second rule of thumb is repeatability. Okay, because we care about the reliability of the result, and sometimes if you can do multiple trials, okay, enhance the precision of the result, that would be great. Okay. All right, so uh, let's deep dive into talk about the procedures. Okay, so for procedures, what you want to do is to list out steps. Okay, and if there are too many steps, it would be also great that you give some subtitles to it. For example, part A is uh, preparing hydrochloric acid solution. Okay, let's say that's the example. Okay, then those procedure one, step two, step three, then it's only about preparing solution. Okay. Maybe the second uh, part B of the procedure is determine the rate of reaction. Okay, then uh, you just list out based on part B. Okay, so make it as clear as possible. Okay, I want to emphasize is that, of course, we should have a procedures that are that can be reproducible. Right? That means the uh, marker should be able to do the whole experiment again in his brain. But at the same time, I want to emphasize that uh, it's not every single detail that you have to uh, add it inside the procedure. Okay? For example, let's say you want to determine the mass of magnesium. Okay? Then of course, maybe in procedure we just say we weigh magnesium and so be it. Okay? You don't have to mention, oh, the first step is that you ask the lab tech for a balance, and then step 2 is I need to the plug it inside the electrical socket so that it can be turned on. Okay, and then step 3 you turn on the electronic balance. Step 4 you put the magnesium onto the balance, and then step 5 you record the mass. Okay, you don't have to write it this detail. Okay, because as long as the marker understand you're actually simply wanting to weigh the magnesium, then uh, like turning on and turning off the electronic balance, these are unnecessary. Okay, unnecessary to be added inside the procedure. You want to only list out the most important procedures. Okay, so the rule of thumb again, you want to list out some of the very important steps in the experiment. Okay, some of the details I want you to edit in as well. Okay, is that, let's say, for example, you mentioned about how to prepare a solution. Okay, then in this case, you say you need a volumetric flask. Okay, but don't just say volumetric flask. You also want to emphasize what is the size of the volumetric flask. Is it 100 cm cube, 250 cm cube, or is it 500 cm cube? Okay, all these are pretty important as well. Okay, yeah. So, right. Let's move on. I think a lot of point I've covered here. Okay. The last point. Okay. Include sampling rate, calibration, standardization if there are any. Okay. Now, sampling rate is talking about, let's say, you need to collect a lot of samples. Let's say, okay, then how do you determine the sample size, okay, of the thing? Even though this is actually very rare in chemistry, okay, like you need to collect a sample size is rare. But let's say if you really do have it, please list it out as well. Okay, the calibration is a little bit more common. Okay, let's say you are doing spectrometry and you need to talk about the calibration curve. Okay, then do have a procedure talking about how you are going to produce that calibration curve as well. Okay, standardization. Okay, also an important part as well. A lot of students just mention when it comes to titration, they say, oh, we use standardized NaOH, okay, to titrate blah 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 blah. Okay. But when you're talking about standardization, okay, please make sure that in your raw data it has standardization raw data. Okay. Otherwise, you cannot claim that the titrant has already been standardized. Okay. And of course, at last in your procedure, make sure that there is sufficient repeats, and at the same time, it is a requirement from the IB that you have 5 points, okay, like 5 plots at least, okay, in the graph. Okay? That is the minimum requirement. Now, after you talk about the procedures, we'll move on to the risk assessment. When we talk about risk assessment, there are 3 things. Okay, even though you don't have to address all of them, especially for ethical, that one might be a little bit rare. Okay, but for safety and environmental concern, you must add it in so that the marker understand you actually put in some consideration, okay, on the safety and the environmental concern. Safety is talking about, okay, are there any chemicals or apparatus that you have to be aware of? Let's say let's say in your experiment where you're actually using concentrated sulfuric acid, okay, is corrosive, right? Then you need to say that it's corrosive, and remember to add in a source as well. The reason is because how do you know that sulfuric acid is corrosive? There should be a secondary source that supports it, right? So do check out some very good websites that talk about uh, the kind of claims that it's corrosive. Okay, usually it could be uh, some of the chem like some of the website that sells chemical. Okay, Sigma Aldrich. Okay, or what else? Etc. Okay, or it could be some of the authority, okay, about chemistry safety. Okay, for example, if I didn't remember wrong, it's MSDS. Okay, if I didn't recall it wrong, okay, it is a authority just for talking about the hazard or safety concerns of the chemicals. Okay, so bear in mind that it has to be very specific to your investigation. Okay, even the safety concern, okay, it has to be very specific to your investigation. Okay, for example, if you're only using dilute sulfuric acid, 0.1 mole per dm cube, okay, then do not say that it's corrosive. Okay, the reason is because it's already diluted. 0.1 mole per dm cube cannot corrode you. Okay, it's not corrosive, so don't over exaggerate it. At the same time, okay, don't write something like when sulfuric acid is consumed, then you are going to die. Okay, don't say something like that, because in your procedures you don't mention that you're going to consume that particular chemical, right? So of course you're not adding that into the safety concern. Okay. About the environmental one, okay, basically what we are concerned of is how you're going to deal with the chemical waste. Okay. So it is a practice where we want to know whether you are conscious about the chemicals that you're using and how you're going to deal with it, okay, and how you're going to minimize the environmental concern. Okay. So for example, if it's an aqueous chemical waste, how are you going to minimize the environmental concern? Are you going to dilute it further before you pour it to the sink? Okay, etc. etc. Okay, you should ask your lab tech, okay, or you can ask the school what their practice is, okay, or if it's not aqueous waste, if it's organic waste, okay, how are you going to deal with organic solvents or some of the organic waste? It should have another way to deal with it because it's organic. Okay. And when it comes to ethical, okay, this one for chemistry is a little bit rare. Okay, the reason is because we don't deal with animals. Okay, so in this case, it's rare, but at the same time, it's not because you deal with animals so you need to deal with ethical concerns. Usually, this happens when, let's say, you are not dealing with an IA that you collect data from primary source. That means you're not doing experiment. All the data that you collect is actually from secondary sources, and you need to compare several data sources. And in this case, ethical concern is something that you should be addressing. Okay, like what are the ethics when you are actually trying to collect or select data, etc., etc. Usually, when we're talking about ethical concern, it's more on this side. So I think for most of you, if you're doing an experiment, usually, like if you cannot find an ethical concern, just might as well don't write it or just say no ethical concern.